Hey guys, thanks again for joining us today. Again, my name is Brice Babinec. I am a 3D printing technician here at MLC CAD Systems, and today we're going to talk about how we fully 3D printed a pocket knife. So, agenda for today's webinar, I'll give you guys a quick tour of our shop, just kind of what we have and what we're working with. I'll show you the machines that we're going to be using, just kind of a brief introduction so you guys can understand how those work. Then we'll go on and we'll kind of quickly go over the anatomy of a pocket knife just to make sure we're all familiar with the parts and pieces and how they're going to work. And from there, we'll dive into the prototype. So we'll do some design review and slicing and printing it just out of a cheap prototyping material. And we'll move on to the final product where we'll make a couple of tweaks to the design, we'll slice it again, and we'll finally print it out of metal. So this is actually an idea that I had within just a couple of months of working at MLC. You know, we're surrounded by all these super advanced printers and machines, and we've got SolidWorks. So sometimes you get one of those ideas that pops into your head, and you got to flush it out. And so this was kind of one of those. It also seemed like a really good opportunity and kind of a challenge to show how diverse of a tool 3D printing is. And of course, as a benefit of that, it would be awesome to have this 3D printed pocket knife to carry around. And so if you guys like this webinar, please let us know because then we get an excuse to make more cool stuff and we can make more content about it. But anyways, the main reason of this challenge and the main reason it is a challenge is because we have all these really advanced printers here. But other than that, our workshop is really pretty simple. So here's a couple of pictures for reference. So here we've got a couple of our composite printers, we've got our metal, and then this is really the sort of meat and potatoes of our shop. There's nothing crazy going on here. I think the fanciest thing we've got are probably our grinding and polishing wheels. Other than that, just some basic hand tools, some vices, and some kind of random hardware floating around. So I don't think most people would look at this shop and think that we were capable of making even a single pocket knife, let alone maybe like a small production run of these things. So with that in mind, it seemed like a really great idea or a great chance to put up this sort of hypothetical scenario where this is a part we need or maybe a product we sell, and we'll work through the process of how we come up with that product. Before I dive too much into that process, I'll give you guys a quick introduction to the machines that we're working with here. That way you kind of have an understanding of how they work and what kind of parts they can make. We've got a ton of content really covering these machines in detail, so I'm not going to go too deep into the weeds, but I think it does help to know what the capabilities of them are and kind of how they function. So diving right in with the Markforged Metal X, which is what we're going to use for printing the metal parts of the knife, of course. This is a three-part system. We've got our printer, which is just an FDM printer basically, but we're using material spools that have metal powder mixed with wax and plastic. So we build up our part cross-section by cross-section or layer by layer. Once it's finished, we pull it out of the printer, we peel it off the print bed, and we put it into the wash, which is essentially just like an industrial degreaser. It gets rid of as much of that wax as we can before we move it over to the sinter where all of those wax and plastic particles are baked away and our metal solidifies into a fully dense part where we can then post-process or work on it however we need to. And so here's a quick just video of the process in a nutshell, just to give you kind of a visual of it. So we print. Once it's finished, we move it over to the wash, pull it out of the wash, put it in the sinter, and then our parts are ready to go. And again, for post-processing, and we can put them straight into use from there. And we could have printed the entire knife and handle and everything using this metal printer, but it's one of the things that we come across with customers a lot where, just because something's always been made for metal or we have metal capabilities doesn't always mean it's the best approach. And same for this knife. There's a couple of parts where we can get away with something cheaper and maybe a little bit easier. And on that front, we're going to take advantage of the Markforged composite printers. And so if you haven't seen these before, they're basically FDM printers on steroids. These things still print plastic parts, but we're printing using nylon that has chopped carbon fiber mixed in with it. And then Markforged has a patented technology that they use where we're essentially ironing in continuous strands of fiber. So here we can see Kevlar, we can have fiberglass, we can use carbon fiber as well. And when you use this thing correctly and you customize your fiber loading based on your scenario, like this link here, you can achieve some pretty crazy things. So in this example, we're looking at a link that was able to hold 22,000 pounds. So really cool option, and it helped me out with the handles of this knife where I wanted to add a little bit more stiffness, but wasn't prepared to go the metal route because it would have also been a lot more heavy that way. So we'll take a little bit more look at that later, but for now, just wanted you guys to understand these two kind of technologies that we're working with. All right, with all that out of the way, let's start getting into this thing. So obviously knives have been around for a long time. I'm not inventing anything new here. It's probably one of the oldest man-made things in existence. And fun fact, I actually Googled it while I was working on this, and the earliest knives were from like 2.5 million years ago. So there's a lot of places to take inspiration here, and some incredible knife manufacturers out there. I unfortunately just had an Amazon knife in my backpack, super cheap one, but you know, it is what it is. You got to start somewhere. So I ended up taking this thing apart and opening it up, kind of playing around with it, and decided which parts I was going to print, how I was going to print them, and what sort of orientations. But basically, when the knife opens, we're going to have a piece that bends up and locks it from closing. And this thing needs to be able to move back and forth to allow us to open and close this knife. We need a couple of washers on either side of the blade to allow it to open frictionless and kind of more freely. And of course, if we're making a pocket knife, we got to throw a pocket clip on it. We're going to need some fasteners and hardware to assemble the whole thing. And then when this blade is open, there's got to be something from spinning it all the way around. So we've got some sort of blade stop for that. And then, of course, we've got two sides of the handles, and you know, obviously we've got a blade that we need to print as well. And like many of you guys probably already do, the best place to start here is with a product in mind. Let's decide what manufacturing process we want to use for each part. And my first thought with these is, you know, again, we could print the whole thing out of metal, but obviously we don't need to. The blade stop, the blade lock, all that stuff probably needs to be metal, but there's no reason the handles can't be plastic, especially when we can reinforce them with fiber. So with that in mind, I popped SolidWorks open and started to get to work. So anytime I'm working on a new 3D printed part, I really try to determine the print orientation before I get too far. And a big reason for that is because there's a lot based around the print orientation. So it's going to decide where you can use overhangs, where the supports are going to be, how the features can be laid out, and where the layer lines are going to be. So with that in mind, I went ahead and started with the blade, and I threw out this sort of rough profile of what I was hoping this thing would look like. And just right off the bat from here, I decided I want this thing to be printed on its back, and I would use a raft because this is a pretty small surface area. So using a raft will keep it from falling over or warping in the center or anything crazy there. And it also opens us up to do some pretty cool things on the side of the blade. So this logo was a pretty good example of that, where when we're using the layer lines to sort of rough out this shape, the height of the layers are 0.12 millimeters, versus if we were going to print this thing just from the top down, we're limited by the bead width of the nozzle, which is 0.4 millimeters. So it's kind of like drawing with a marker versus drawing with a fine tip pen here. One of the other things I did was use a revolve cut to sort of sharpen this blade. But for the same reason, I left sort of a flat edge at the top because I want this to be printable still. And I'll come back later on and I'll sharpen this thing and get it ready to go for an actual knife. The last thing worth mentioning is I knew I wanted to use some sort of plastic washer or spacer to fill in this hole because this is going to be approximated with layer lines. And it's going to be a little bit more of a friction-y type surface. So I didn't want to put a screw straight through here. And we also don't have a drill press. Again, we've got a really simple shop. So I wouldn't be able to rough this thing out to the perfect size. So at this point, I was pretty happy with how this blade came out. I was starting to get pretty excited. But it was at the end of the day, and so it was time to go home. But I had a feeling I was going to keep working on this at home. So I went ahead and I loaded up our Mark II and our X7 with our just sort of cheap prototyping plastic, which is just a PLA. And I put black and gray in there just in case I wanted to kick it off from home, which is exactly what I ended up doing for the rest of this thing. So for the rest of the blade, this is what I ended up coming up with just for the prototype. So I worked on the handle next, and I didn't want to spend a whole lot of time on aesthetics here before I knew if everything was going to kind of fit and function together correctly, if it was going to be the right size, and just kind of how it felt. So just made a simple sort of rectangle and cut out a thumb spot for the blade lock. And I had an idea of some hardware that we had at work already. So just added a cutout for the bolt hole and for the bolt to go through. And on the other side, I added some cutouts to use heat set inserts that just melt into the handle, and they would add some thread. So other than the handle, I decided to go ahead and print the blade lock just flat as opposed to already bent into place, because then I would have supports underneath it that I have to pull off. And it's honestly just as simple to print this thing flat where I don't have to use a raft or supports. I'll bend it up later, and I oversized this edge a little bit so I can file it away just so it's an exact fit where it locks this blade open. I also thought it would be probably a good idea to add this little nub here where it actually locks into one of these little hexagon cutouts. See if I can get this thing closed. That way, this thing doesn't open up while it's in my pocket and cut my leg open. Thought that was probably a pretty smart thing to add in there. I also, instead of using like spacers back here, it's just as simple for me to add this all as one part. So these things will print together as one piece. The last kind of big piece of the puzzle is the blade stop at the very back. And this is one of those things that we kind of preach to our customers a lot. We could get away with printing this little cylindrical piece, but I know we have a pack of dowel pins at work just for this exact purpose. If you can use cheap off-the-shelf hardware to work with your 3D prints, sometimes it's a better option. So I went ahead and added the hole just for some dowel pins I knew we already had. Other than that, I set up these washers and one of them to go through the actual blade, and it just presses into the hole. And that way it's set up correctly for the bolt that's going to be going through here. So once I was happy with this whole setup, I went ahead and opened up Eiger and kicked this thing off to be ready to come into the next day. And here's a sped up video of how I laid these things out in Eiger. I went ahead and uploaded all of the gray parts first because you can actually batch edit the settings for them all at once. And so I set everything up as gray, set the layer height for all of them, and I wanted to make sure I added a brim on this knife. So double checked that and added all of it to a build for the X7 and went ahead and kicked that thing off and then moved on to the black parts. So same deal here, uploaded them all as a batch, reoriented them, and then changed the batch settings all at once. And then aligned those on the Mark II build plate and went ahead and kicked that thing off from home as well. So I woke up the next day, went to work, and I had these things already sitting there on the print beds waiting for me. So I went ahead and first thing I did was scrape them off and started kind of putting things together. So the first thing I did was push the spacer into the blade. I went ahead and melted those heat set inserts into the handle so I could have thread. Got the dowel pin, got my hardware, and put this thing together. And it did exactly what I needed it to do. It gave me a thing that I could hold in my hand and touch and feel and make sure that the blade swung around, it stopped, and everything was the right size. And I did all of that for, I think it was about $1 in materials. So, and it did it overnight, kicked it off from home. So just super convenient to be able to do that and have this prototype before I go through the process of printing this thing in metal and spending a little bit more money. So the main problems I had with this was obviously these screws were a little bit too long, so I wanted to do something a bit different there. And even more than that, I didn't really like how these heat set inserts looked. I wanted something a little bit more simple and maybe hidden away. And the best way to do that is by embedding square nuts inside of this part. That way the thread is in there, but you still can't see the thing that's creating the thread. So the other part of it that I knew I wanted to change was, of course, this handle. It did the job. It gave me what I needed it to for fit and function, but the blade looks really cool, and this just doesn't work for me. So I know I've got to change something up there. And then lastly, there's got to be a pocket clip on here. You can't have a knife without a pocket clip. So with all that stuff in mind, I went ahead and I opened up SolidWorks and got started on making some changes. And this is what I ended up coming up with. So much happier with the way that this handle looks compared to the old one. Definitely complements the blade a little bit better. And as part of this handle, I took away those heat set inserts and I went ahead and added these cavities. So this is where during printing, I'm going to add a pause. I'll put a square nut inside of this part and then I'll continue the print. It'll print right over top of where that square nut is, and that will be captured inside of the part, and I'll have a thread sitting there ready to use. So just a quick and easy way to get away with that. And that way it's ghosted into the part, and all I'm going to see is just sort of the top of the bolts that are coming out here. Other than that, the internals are pretty much the same here. The blade lock, I did have to play around with the shape of it just to get it to match the handle a little bit better. But I did leave myself just a little tab here that I could file away at and make it match the spot on the blade when it does lock into place. And then otherwise, I added my pocket clip like I wanted. This, of course, could have been printed out of plastic, but I just think it definitely artistically matches the blade a little bit better. And I planned to print this in the same orientation, so on its back, as I'm spinning around here. On the back, just like the blade. That way when it's open, these lines, actually the layer lines will match what's going to be on the blade. So the only thing that I sort of had to fight against here is I didn't have a whole lot of space to work with after I created the handle. So with just one hole, this thing is going to be spinning around. But one of the other things I was worried about too was with how this thing is shaped and the size of it, it might have issues falling over during either printing or sintering. So it gave me the perfect excuse to just add this little tab on here. So this thing slots into the onyx or the plastic and keeps it from rotating, but it also keeps this part from falling over at any point during printing and sintering. So from there, was really happy with the way this turned out, and I was ready to kick off this final product, start slicing it and printing it and see what we could come up with. One of the great things about using just the Markforged printers and their ecosystem in general is that we've got the same slicer no matter which printer we're using. So it's going to be the same workflow here. I uploaded all of my metal parts at once, and I batch edited the settings for all three of them to switch them to metal. That way I don't have to open it and do it part by part. And so I had my blade laid out the way I wanted it. Again, I changed them all to 17.4 stainless steel. And you always want to look at the x-ray view before you're printing something just to make sure everything sort of makes sense here. And this shows where I had to make one small change, which was adding a support blocker. So you just draw out a shape and bring it up however many layers you need, because it wanted to fill in the logo with supports. And I knew that was going to print just fine. And same with these where it can bridge. I'm not worried about those drooping. These ones maybe a little bit more. And you can see that there's actually an orange interface here. And that's one of the unique things about the Metal X system is, so when it goes into the center, this thing is going to shrink a little bit, and the software accounts for that. But we want our supports to be made out of the same material, so it all shrinks uniformly. But if the supports and where they interface with the part are all metal, then we're going to have issues because we've just got a chunk of metal in there and we're going to have to like cut it or grind it out. So everywhere where you see orange, we're actually using a second nozzle in the Metal X print head, and it lays down a ceramic release material that turns to powder during sintering. And so when you pull it out of the sinter, we can actually just pop all of these supports off or out, and we can pull the blade right off of the raft, no problem. So the only other thing that was a bit funky here is I knew that the blade handles, I knew I wanted them a little bit stiffer. And so I decided to go with an onyx for all of my parts, which is a nylon 6 with chopped carbon fiber. But I wanted to reinforce these handles with fiberglass. It's just a quick and easy, kind of cheaper fiber. I didn't need a huge amount of strength out of it, but I did want some more, so that's what I did here. And you can see in this view, it's exactly how you want to lay out fiber when you're working with it. You set them up in these sandwich panels, so whenever you have a force coming in, we've got our highest tension and compressive forces on the top and the bottom of this part. So we just set up groups of fiber in a concentric or an isotropic fill where it just fills the entire layer during those groups. And then the other thing I wanted to do was reinforce a couple of these bolt holes, especially the one where the blade is, because I'm going to be putting a little bit of force on that thing as I'm kind of going through and cutting stuff. So if I add some fiber, it'll stiffen it up and it'll add some strength. So did that a little bit more in the middle as well, again at the top, and another group of isotropic fiber at the top as well. So once I finished up with all my slicer settings, I went ahead and sent these things over to their respective printers and let those print. Once they were finished, I peeled them off and got to work on kind of post-processing and putting things together. I actually put together a sort of quick build montage video for you guys, so here's what that process looked like.
Well, slide this says has everything on it. Yeah. Yeah. This says this is sizes, right? We'll talk about it.
All right, so overall, I'm really happy with the final product. having that first prototype worked perfectly to iron things out before going through the whole metal process. And it also gave me the confidence that everything would sort of just fall into place once I did. And so now the reward of all of this is that I've got this perfect little pocket demo piece that I can take to customers and sort of show them how these different processes can work. And it's also something functional that I can use every day. So I hope this was as entertaining for you all to watch as it was for me to make. And I hope it gives you a bit of a glimpse into some of the capabilities of our 3D printing technologies. We're going to stick around now and we'll try to answer any questions, but feel free to reach out to us later on if something comes up. We're always happy to try to help you find out where and how you can use 3D printing to improve your manufacturing capabilities. But for now, I'm going to go ahead and pass this back over to our marketing team. So thanks very much for hanging out with us and sticking around today.